Okay, ladies and gentlemen, this PowerPoint is not made by me, so I got it from SlideShare. So for this one, we are going to look at the basic concept of thermodynamics. So thermodynamics comprises of two words, thermo and dynamics. One which a thermo means heat, then dynamics means motion under action of force. There is the change of the change or the motion or how one form of energy is changed to another. So thermodynamics is the branch of science dealing with heat or work. Broadly, energy interaction and related changes in the physical properties of substances. So I think I have explained this in the previous video, so I don't need to waste too much time here. So now the next thing is under this thermodynamics, we have macroscopic and microscopic approach. So under macroscopic approach, we have a quantity of matter is taken into account for analysis. Then it does not consider matter at molecular level. So when you said from the word macro means a larger molecules, a larger. So we are talking about the quantity of matter is always considered in macroscopic, and this kind of approach is made in classical thermodynamics. So we usually have a macroscopic approach usually in classical thermodynamics, while in microscopic, in this approach, analysis is done on molecular level. It's done on molecular level, that is the smaller molecules. The analysis is usually done at molecular level by adding up the behavior of each molecule's analysis. And this kind of approach is usually made in statistical thermodynamics. So one thing that we need to understand here is very, very important. Number one is, what is a system? A system is a region or space for a study. So look at this thing, what we have here. This is a system. So in this system, you can see that a system is a region where the processes, reactions are taking places, while the surrounding is what is outside the system, while the boundary is usually in between the system and the surrounding. So it's a demarcation line between the system and the boundary. So surrounding is everything external to the system is surrounding. So anything outside the system is a surrounding. And then we have what you call universe. So universe, a system and the surrounding together constitute a universe. Let's assume you are in a classroom, and in the classroom a lecture is taken on. So the classroom are considered as a system, and what is ever outside that class is considered as a surrounding. So this system plus the surrounding is what constitutes what you call a universe. Okay, so then the next thing that we are going to look at is the next thing after this. We are going to look at the types of system. So ladies and gentlemen, we have different types of system. We are starting with an open system. What is an open system? An open system is a system where both mass or matter and energy can cross the boundary. So the matter and energy can cross the boundary. So look at it here. In this, we see that we have our energy here and we have mass. So we can now see clearly from here, mass and energy can leave the system and as well as can enter the system at the same time. So there is an exchange between the system and the surrounding of matter and energy. An example of this, we have pump, we have compressor, we have turbine engine, and we have heat exchanger. So these are a typical example of an open system. Then the next one, we have closed system. A closed system is a system where mass or matter cannot exchange between the system and the surrounding. So that is why you see in this case the matter is cancelled, meaning that it cannot go in or outside the system. So that one, but look at it, the energy can go in and out of the system. So there is an exchange of energy between the system and the surrounding. So this type of system is known as closed system. Then the next thing is an isolated system. In the isolated system, there is no transfer of energy and matter across the boundary. So this is this. And one very important thing is, if I ask which types of system is the universe operating, remember we said the system from system plus the surrounding is what constitutes the universe. So now if I ask this question, which type of system is the universe operating? The answer is open system. Because we are operating on open system, that is what even makes the life possible on Earth. Okay, then the next thing is thermodynamic properties. The next thing is thermodynamic properties. These thermodynamic properties, we have properties that used to define the characteristics of a system. So we usually use them to characterize the types of the system that we are dealing with. So examples of these properties, we have pressure, temperature, volume, mass. So thermodynamic properties are mainly divided into two. We have number one, we have what you call extensive property, and we have intensive properties. Extensive properties are properties that are dependent on mass, that depend on the mass of an object. In the other way, we can say that it depends on the amount of a substance or the quantity of matter and present in the system. So it depends on the quantity or the mass or the amount of a substance in the given system. So examples of these extensive properties, we have volume, we have energy, we have enthalpy, we have Gibbs free energy, we have heat capacity, we have entropy. So all these are typical examples of extensive properties. Extensive properties are just in a simple way, they depend on the amount of a substance. They depend on the matter, the quantity of that particular substance. So that is extensive properties. While intensive properties are properties that are independent on the mass and the amount of the substance. And examples of these intensive properties, we have pressure, we have temperature, we have boiling point, we have freezing, we have refractive index, we have viscosity, we have electromotive force, surface tension. All these are a typical example of intensive properties. So these are the properties in thermodynamics. Then the next thing is the states. Conditions of a system describe its properties. So of course, in the system, we can have different substances that are present in that system, and also they can be in different states. They can be in a solid state, they can be in a liquid state, they can be in a gaseous state. Then the next thing that we are going to look at is a process. Process is when system changes from one state to another, then it is called a process. So in a system, if that system is changed from one state to another, then the system is now called a process. So it's not longer called a system. So now two things are important here. We need to know the differences between the process and the system. So a process is a region where processes are taking place. So when system it's change or change state from one point to another, then it is now called a process. And this process are classified into different types. We have what they call reversible process, irreversible process, and we also have what you call cyclic process. So now, what is a reversible process? A reversible process is a process when reverse do not leave any effect on the system and surrounding, or it can goes back to its original state. So in a situation where we said a reversible system is like in a chemical kinetics, a reversible process is a process that can occur in both forward and reverse directions. That is, let's say if you have A and B to produce C and D, and at the same time that C and D can also go back to its A and B. So that is what you call a reversible process. So it's a system when the process occur, then it reverse, and the reverse do not leave any effect on the system and the surrounding. So that is, however, in thermodynamics, a reversible process is a process that takes place infinitesimally or slowly, such that the driving force is only infinitesimally greater than the opposing force, and at any point the direction of the forces can be reversed by the infinitesimal change in the state of the system. On the other hand, we have a reversible process. A reversible process is a process which cannot be reversed to its original state. And then the next thing is a cycle. We have a cyclic process. What is a cyclic process? A cyclic process or a cycle process is a sequence of different processes whose initial and the final states are the same. It means that it's a system where there is a series of changes from one state to another, but finally it will now come back to the original state. That is a cyclic, and that is that. So then the next thing that we are going to look at is the point function and path function. Point of function, a property whose values depend on end states. So it's a point function. The properties only depend on the end states. Exact or perfect differential. So example, we have pressure, temperature, and volume. Then we have path function. The path function properties whose value depend on the path, that is in exact differential. So we have work and heat. So these are the path and point functions. The point functions depend on the end state, while the path function depend on the different states, that is not the end. From, let's say we have point A, B, C, and D. So the path function can actually, or is a properties that can depend on from state A, state B, state C, state D. While for the point function, if you have A, B, C, A convert to produce B, B produce C, C produce D. So the point function will only depend on the end product, which is D. It doesn't concern about the B, the C, and what is also happening there. Okay. Then the next thing is thermodynamic equilibrium. A system is said to be in thermodynamic equilibrium if it satisfies the following three conditions. Thermal equilibrium, there is no temperature differences between the system and the surrounding. So that is what you call thermodynamic equilibrium. Then mechanical equilibrium, no unbalanced forces between the system or with the surrounding. So it means that the forces between the system and the surrounding are equal. Then the next thing is chemical equilibrium, no chemical reaction and no change in chemical composition. So that is what you call thermodynamics equilibrium. So for a system to be in a thermodynamic equilibrium, thermal equilibrium, mechanical equilibrium, and chemical equilibrium must be within, or must be the same between the system and the surrounding. So thank you. These are some basic information on on some thermodynamic parameters.